Okay, today we are talking about writing equations from tables. So independent and dependent variable. We're going to skip the do now. So here is your vocabulary for today. It says an independent variable is one that is not influenced by another variable, and the value of the dependent variable relies on the values of the independent variable. So in other words, the dependent depends on the independent. So let's look at an example. It says Frank earns $8 per hour mowing his neighbor's lawns. So we have to figure out which one's the independent and which one's the dependent variable. It says the amount of money he earns depends on how many hours he works. So the money he earns depends on how much he works. So the more he works, the more money he makes. So then in that case, the dependent variable would have to be the money, and the independent variable would have to be the hours. Because the hours he works does not depend on the money he makes. So if I look at this example, I'm going to find the output. We need to always remember that the output is the dependent variable. So if I look, this is going to be the dependent. I'm going to label it dv for dependent variable. So if this one's the dependent, then this one also has to be the independent variable. But if we remember from looking at tables and graphs at the beginning of the year, this side is also your x value, and this side is also your y value. So then if my input is x, my output I'm going to be doing a 2x, which means I'm going to be multiplying by a 2. So if I plug in this 10 for the x, 10 times 2 would be 20. This one, 20 times 2 is 40. On the last one, 30 times 2 is 60. So I have filled in my table with my independent and dependent variables. I can now look over here at my graph and I can graph them. My independent is going to be my x, and my dependent will be my y. So I'm going to label each of these little marks as a 10. So each line is going up by 10s. If we remember from the beginning of the year, my first number is the x, my second number is the y. To graph something, I have to graph x first and then y. So I go over and then up. So I'm going to start at the middle, going to go over to the 10, up to the 20. The next one I go over to the 20, up to the 40. Next one I would go over to the 30 and up to the 60. So once I graph those dots, I can then connect them with a line. So I have now graphed my independent and dependent variable. Let's look at the next example. So I am given the equation y equals x plus 3. So I know that this column here is going to be the x plus the 3 to get me the y. So the x is always going to be my independent variable, and my y will always be my dependent variable. So to graph this, I just go start, and I'm going to have these as 2. So I can go over to the 3 and up to the 6. Over to the 4 and up to the 7. Over to the 6 and up to the 9. I can also connect those 3. So now I have graphed my equation from my table of the independent and dependent variable, and I've graphed it. So now I can answer these questions at the bottom. What is the independent variable? The independent variable is always going to be the x value. The dependent variable will always be the y value. Independent is always x, dependent is always y, because the y always depends on what happens to the x. Here's this one. It says the manager of the department store raised the price $15 on each video game. So first, which one's going to be my independent variable? It would be the original price, because that's the x value. Which one would be my dependent? Is going to be the price after the markup. So now I can fill in this table based on the information I was given. He raises the price $15 on each video game. So I would have to take the original price and add $15 to get the price after the increase. So 100 plus 15 is going to be 115. 55 plus 15 is going to be 70. And then 38 plus 15 would be 15. $43. No, $53. $53. So now can we look at that and can we find an expression or a rule that will satisfy the total cost of the video game if given the original price? So if we don't know the original price, can we find a rule that we can do to whatever x equals, we could figure it out? The rule would end up being x plus my 15. Because whatever number I put in for x, I'm going to have to add 15 to get the total price after the markup. So this y value is going to depend on the x value. Here's this example. Natalie is going ice skating. The skating rink charges $6.25 per hour of skating. We're going to let H represent the number of hours and C represent the total cost. So I'm going to give you guys a few minutes to figure out the table and the graph on your own. Okay, so now that you've had time to work on this, you're going to have H represent the number of hours and C represent the cost. So the C is going to be over here. Oh, hold on, my screen went black. There, now you can see. Okay, so the cost will be over here, and the hours is going to be over here. So if she skates for 1 hour, the cost is going to be $6.25. If she skates for 2 hours, the cost is going to be $12.50. And if she skates for 3 hours, the cost is going to be $18.75. So my equation is going to be the cost, C, equals my number of hours, how many hours I skate, plus my $6.25. So then I could graph that over here. I could say that this is 1 hour and that this represents the $6.25, and I can put a point right there. Then the 2 and the next one would be the 1250. And then for 3 hours, we had 1875. I connect my dots to make a line. And we answered this question at the bottom already by filling in our table. Okay, that is all that we are learning today. Tomorrow we will do a project on independent and dependent variable.